Welcome to this special episode of AI Frontiers, where the latest breakthroughs in computational linguistics are explored through a curated synthesis of 47 research papers, all published on May 18, 2025, and sourced from the arXiv preprint server. This episode is designed to highlight the cutting-edge developments that are shaping artificial intelligence's understanding of language. The discussion will spotlight the most significant findings, major research trends, and methodological innovations that have emerged from this recent body of work. Listeners will gain insights tailored to practitioners, researchers, and anyone intrigued by the science behind how machines process language. Key topics covered include advances in large language models, the creation and evaluation of new datasets, developments in explainability, and the challenges and opportunities that lie ahead. Throughout this episode, a journey will be taken through the essential themes, critical discoveries, and future directions that define the evolving landscape of computational linguistics. To provide context for the research discussed in this episode, a brief overview of computational linguistics is necessary. This scientific field stands at the intersection of linguistics, computer science, and artificial intelligence. Its central aim is to develop computational methods and algorithms that enable machines to understand, interpret, and generate human language. Computational linguistics underpins a wide array of applications, including automated translation systems, conversational chatbots, and digital assistants that help manage daily tasks. The field confronts the inherent complexity and ambiguity of human language, addressing issues such as context, idiomatic expressions, and multiple meanings. By equipping machines with the ability to process language in a manner that is both meaningful and accurate, computational linguistics serves as a cornerstone for trustworthy and impactful artificial intelligence systems. A central research theme emerging from recent studies is the advancement of large language models, commonly referred to as LLMs, and their capacity for text generation. Developments in this area include the ability of LLMs to generate ultra-long documents with enhanced coherence, as demonstrated by Shen and colleagues. Hierarchical modeling techniques are being employed to address the issue of semantic drift in extended texts, ensuring that generated content remains consistent and contextually relevant. Domain adaptation methods are further boosting performance in specialized language tasks, such as patent claim generation, as explored by Jiang and collaborators. The collaboration between humans and language models is advancing both creative and technical writing, illustrating the growing influence of LLMs not only in consumer applications but also in scientific, legal, and educational contexts. The enrichment and development of data resources constitute another foundational theme within computational linguistics. High-quality datasets are essential for advancing the evaluation and training of language models. Notably, the tagged PBC corpus introduced by Rain and colleagues enables large-scale cross-linguistic analysis by covering more than 1,500 languages, thus supporting typological and empirical studies. Structured question-and-answer datasets, such as those proposed by Tataranov and collaborators, provide systematic frameworks for assessing long context and knowledge-intensive tasks. Domain-specific corpora are being leveraged to improve model performance in real-world applications. The diversity, representativeness, and annotation quality of data resources are recognized as critical factors for building robust and generalizable artificial intelligence systems. Further key research themes include explainability, robustness, and the integration of multimodal data sources. Explainable artificial intelligence frameworks, as proposed by Jiang, Madani, and their respective teams, are clarifying how language models arrive at specific decisions, thereby increasing transparency. Robustness is being systematically studied in tasks such as named entity recognition and relation extraction, with Arst and Ding investigating how models handle noisy or out-of-domain data. Multimodal models, exemplified by the work of Zhao and colleagues, are fusing textual, visual, numerical, and behavioral data to provide richer and more comprehensive insights. Additionally, cognitive-inspired modeling approaches, such as those explored by Jiang and Wu, draw on human reasoning strategies to enhance model learning. Collectively, these advances reflect the growing demand for artificial intelligence systems that are both trustworthy and adaptable. A technical concept central to recent progress is hierarchical modeling in large language models. Hierarchical modeling is a strategy that decomposes complex generation tasks into a series of manageable stages. Large language models, as demonstrated by Shen and collaborators, utilize structured outlines to guide the generation of long and coherent texts. This approach has proven effective in reducing information loss and semantic drift, which are common challenges in extended text generation. By balancing the amount of human input with the quality of automated generation, hierarchical modeling expands the applicability of language models in creative and technical domains. The adoption of multi-stage generation pipelines is thus facilitating more reliable and scalable language processing. Several critical insights have been identified across the current landscape of computational linguistics research. Notably, two-stage generation methods have been shown to significantly reduce distortion in ultra-long text outputs, as detailed by Shen and colleagues. Domain-specific datasets, such as those curated by Jiang and collaborators for patent claim generation, have demonstrated substantial improvements in performance and generalization. The tagged PBC resource developed by Ring and team has uncovered universal linguistic patterns, enabling empirical investigations across a diverse range of languages. Analyses by Cooper and colleagues reveal that memorization behaviors in large language models are highly variable, raising important legal and ethical concerns. Furthermore, multimodal artificial intelligence frameworks, such as those introduced by Jiang, have achieved notable gains in real-world predictive accuracy, particularly in high-stakes domains. Methodological innovations are driving the field forward. Hierarchical and multi-stage modeling approaches, such as those implemented by Shen and colleagues, structure complex tasks into sequential steps to improve output quality. The assembly of large-scale, annotated corpora, as demonstrated by Ring's tagged PBC and Yang's domain datasets, underpins the generalizability and empirical rigor of language models. Explainable artificial intelligence tools, developed by Jiang, Madani, and others, provide valuable insights into the reasoning processes of models, fostering greater user trust. Multimodal frameworks, exemplified by Zhao's research, enable the integration and alignment of diverse data sources, enhancing the richness of model outputs. Additionally, self-questioning strategies investigated by Wu and colleagues are expanding the domain expertise and introspective abilities of language models. A pivotal study in this research collection is the hierarchical novel generation framework developed by Shen and collaborators. This study addresses the challenge of generating ultra-long novels using large language models. The authors introduce a two-stage expansion process, beginning with a high-level outline and progressing to a detailed manuscript. This method identifies an optimal balance between human input and the quality of generated content, effectively reducing semantic drift and information loss. Empirical validation demonstrates that this hierarchical approach yields more coherent and contextually faithful texts. The significance of this research extends to creative writing and collaborative human-AI authorship, offering a practical framework for integrating computational models into the creative process. Another landmark analysis is presented by Cooper and colleagues, who investigate memorization in large language models, especially concerning copyrighted content. Using adversarial machine learning and probabilistic extraction techniques, the authors systematically probe open-weight models for the presence of memorized passages from copyrighted books. The study reveals a wide variation in memorization behaviors depending on both the model and the source material, with some models capable of reproducing substantial portions of popular works. This nuanced analysis informs ongoing copyright debates and establishes standards for the auditing and refinement of language models. The findings underscore the necessity of responsible data curation and the implementation of safeguards to mitigate the risks associated with content memorization. A groundbreaking resource in the field is the tagged PBC parallel corpus, developed by Ring and collaborators. This dataset includes part-of-speech tagged parallel text data across more than 1,500 languages, enabling empirical studies of language universals and typological diversity. The introduction of the N1 ratio, a feature that predicts word order typology, represents a methodological innovation with predictive accuracy validated against expert databases. Tagging accuracy within the corpus is found to be consistent across language families, supporting robust cross-linguistic analysis. The open availability of tagged PBC establishes a foundational resource for inclusive, data-driven research in both descriptive and computational linguistics. Looking ahead, several transformative directions are poised to shape the future of computational linguistics. Human-machine co-authorship, facilitated by hierarchical generation techniques, is expected to revolutionize creative work. The continued expansion of larger and more diverse annotated datasets will support the development of inclusive and representative artificial intelligence systems. Advances in model introspection and self-questioning are anticipated to unlock new levels of expertise in specialized domains. However, legal and ethical challenges, particularly those involving copyright and data privacy, will require interdisciplinary collaboration. Robustness, explainability, and transferability remain critical challenges that must be addressed to ensure reliable and equitable deployment of language technologies. Explainable artificial intelligence, also referred to as XAI, is emerging as a core requirement for building trust in language models. XAI frameworks, such as those developed by Jiang and others, clarify how artificial intelligence systems arrive at specific decisions by providing multi-level linguistic explanations. These tools not only increase user trust but also assist researchers and developers in debugging and refining models. The balance between interpretability and predictive accuracy is a key consideration, especially in sensitive domains where responsible and transparent deployment is essential. As language models are increasingly integrated into high-stakes applications, the role of explainable artificial intelligence will become ever more central. The synthesis and review process underpinning this episode involved state-of-the-art artificial intelligence tools and expert oversight. The research narrative was generated using GPT 4.1 by OpenAI, with text-to-speech production conducted by Google and all visuals created using OpenAI's suite of tools. Human experts reviewed the entirety of the AI-generated content and references to ensure technical accuracy and clarity. Listeners should note that, while every effort was made to eliminate errors, some oversights may persist. For comprehensive details and further information, the original cited papers are recommended as primary sources. This process underscores a commitment to maintaining rigorous standards in scientific communication. For continued engagement with the latest developments in artificial intelligence and computational linguistics, listeners are encouraged to subscribe to the AI Frontiers YouTube channel. Stay informed on the newest research breakthroughs and join a community dedicated to expert insights and informed discussion. Thank you for joining this exploration of the frontiers of artificial intelligence. AI Frontiers remains committed to unpacking the evolving science and societal impact of artificial intelligence.